A mysterious object has quietly passed close to the Sun and no one is sure what it is. Although it is no longer visible through telescopes, scientists have been tracking its orbit for months. They have named it 3I Atlas, or the catchy name for interstellar comet, a visitor from deep space traveling through the cold to visit our solar system. In just 4 months, nearly 100 studies on 3I Atlas have been published. However, scientists say there is still much to discover, and theories that seem like they belong only in science fiction. Some have suggested it is an ancient fragment of a distant star system, while more daring ideas have suggested that 3I Atlas could be an artificial object sent by an extraterrestrial civilization, similar to previous theories about Oumuamua. Stay tuned, because what happens next will blow your mind if you are intrigued by the mystery of the 3I Atlas. And comment below and let me know where you are watching this from. I would love to see what corners of the world are witnessing this with me. So, with 3I Atlas in this vast universe, is it just an ordinary comet, or the first sign that we are not alone? Let's explore the mysteries that science is trying to solve about this strange interstellar visitor. According to astronomers, the interstellar object 3I Atlas is entering the most spectacular phase of its journey through the solar system. On October 29, it was determined that it would reach perigee, the point at which 3I Atlas is closest to the Sun, at a distance of approximately 210 million kilometers, equivalent to 4 astronomical units, AU. While this distance may seem large on a cosmic scale, it was a dramatic encounter. 3I Atlas is currently orbiting Mars, where the Sun's heat and radiation are at their peak. Under the influence of high temperatures, ice and dust on the comet's surface quickly evaporated, forming a bright tail that stretched for thousands of kilometers. Scientists believe this is the ideal time to observe and collect data, as the comet's nucleus gradually revealed traces that could correspond to ancient ice or strange matter never before recorded in space. According to experts, the phenomenon occurring on 3I Atlas is sublimation solid matter changes directly to a gaseous state without going through a liquid phase thanks to the vacuum of space. This process creates a halo around the comet called a coma, along with a long tail created by the solar wind. Every speck of dust and every jet of gas in the gas cloud reflects sunlight, creating a dazzling and eerie spectacle. However, the moment 3I Atlas reaches its peak brightness cannot be directly observed from Earth, because our planet is located on the opposite side of the planet from the Sun. The intense light from the central star completely blocks out ground-based observations. Despite this, space telescopes continue to collect data from afar to recreate the phenomenon, considered one of the most impressive natural spectacles of the year. 3I Atlas was discovered in July 2025 by the Atlas Asteroid Collision Warning System, a network of telescopes based in Hawaii, Chile, and South Africa, whose mission is to detect objects that could pose a threat to Earth. Initially, the object was recorded as a slow-moving asteroid with no apparent abnormalities. However, subsequent observations showed that it was moving faster than any asteroid discovered so far in the vicinity of the solar system. Its orbit did not follow the usual laws of gravity, forcing scientists to reconsider all data. Analysis confirmed that 3I Atlas was not part of the solar system but an interstellar object. It is the third interstellar object discovered by humans after 2017's Oumuamua, and 2019's 2I Borisov. Currently, observatories around the world are closely monitoring the orbit of 3I Atlas as it moves behind the Sun. Data collected during this period could help clarify the structure, composition, and origin of interstellar objects, messengers carrying valuable information about other planetary systems in the Milky Way. Scientists hope that 3I Atlas will expand humanity's understanding of how comets form and reveal the possibility of the existence of artificial objects or traces of technology from extraterrestrial civilizations. But behind that hope lies a question that has both astronomers and conspiracy theorists. Curious what brought 3I Atlas here. Is it just an ancient ice block that was thrown out of its star system? Or is it a silent messenger traveling through the darkness of space to observe Earth without revealing its identity in the universe? All objects are constantly moving under the influence of gravity. Planets orbit the Sun because they are held by the star's gravity. The closer they are, the faster they must move to avoid falling in an object that reaches escape velocity, that is, reaches a speed great enough to escape the Sun's gravity, will plunge straight into interstellar space and leave the solar system forever. When astronomers measured 3I Atlas's speed, they immediately noticed something unusual. It was the fastest object ever observed in the solar system. Earth orbits the Sun at about 30 kilometers per second, a speed that is already far beyond the capabilities of any current technology. Mercury, the planet closest to the Sun, must travel at 48 kilometers per second to maintain its orbit. Yet at the time of its discovery, in July 2025, 3I Atlas was hurtling through space at 58 kilometers per second, far exceeding any planet in the solar system. Even more strangely, it reached this speed while still very far away inside the orbit of Jupiter, nearly 1 billion kilometers from the Sun. At such a speed, there is almost nothing that can hold it back. 3I Atlas will travel through the solar system, skim the Sun, and return to its endless interstellar journey. Analysis of its trajectory shows that 3I Atlas is moving along a hyperbolic path, the open orbit typical of objects outside the solar system. This means that one thing is certain: it will visit us only once, then disappear into the cosmic darkness and never return. On October 29, as 3I Atlas approached its closest point to the Sun, observatories around the world turned their attention to this fleeting visitor. This was considered the last chance to capture precious images and data before it disappeared from human sight. Was 3I Atlas just an ancient iceberg melting under the heat of the Sun, or an object carrying a message from a distant civilization that science has yet to decipher? The answer is still beyond reach, but it is certain that after the moment 3I Atlas leaves, humanity may have to wait centuries to witness a similar phenomenon. The name 3I Atlas is self-explanatory. It is the third interstellar object ever discovered by humans. Before it, there were only 2 other visitors to the solar system, and each one carries its own mysterious story, waiting to be deciphered by humans. The first visitor, Oumuamua, discovered in 2017, surprised the scientific community with its unusual shape and puzzling behavior. Unlike any comet or asteroid ever seen, it lacked a dust tail, reflected light in strange ways, and even changed speed in ways that gravity could not explain. Some scientists even boldly hypothesized that Oumuamua could be a man-made probe from another civilization. The second object, Druki Borisov, discovered 2 years later, was much more normal. It had all the hallmarks of a typical comet: the icy nucleus, the halo, and the characteristic dust tail, except that it came from outside the solar system. So, despite being a significant discovery, 2I Borisov quickly faded into obscurity in the scientific community. 3I Atlas differs from the previous two versions in three main aspects: size, speed, and direction of movement. First, the size. While Oumuamua was only about 400 meters across and Borisov was about 1 kilometer in diameter, 3I Atlas is estimated to be 6 kilometers in diameter, making it many times larger than the previous two objects. This makes it the largest interstellar object ever discovered. Next is speed 3. I Atlas moves at an average speed of about 58 kilometers per second, twice as fast as Oumuamua and Borisov. That's enough speed to completely overcome the sun's gravity, sending it into a hyperbolic orbit, an open path that would allow it to leave the solar system forever. Finally, what surprised scientists most was its direction of motion. 3. I Atlas did not come from a random region of space, but appeared to originate directly from the core of the Milky Way, the bright region in the night sky, where the density of stars is greatest. Orbital data combined with optical observations suggest that 3I Atlas likely originated in the central region of the Milky Way, wandering for billions of years before suddenly crossing the solar system. When astronomers reconstructed its motion in 3 dimensions, they found that the object's orbit was not in the galactic plane like most ordinary comets, but originated in the thick disk region, the layer of ancient material surrounding the thin disk of the galaxy. This is a quiet region with almost no supernovae, cosmic collisions, or black hole impacts, making it a primitive archive of the Milky Way. Simulations of the comet's age suggest that 3I Atlas may have formed around 6 billion years ago, nearly twice the age of Earth. If confirmed, it would be one of the oldest interstellar objects ever recorded, carrying chemical remnants from a time when the first stars were forming. This has attracted particular interest from the US scientific community, where agencies such as NASA, NSF, and leading universities are collaborating to analyze spectroscopic data to find out the composition of this cosmic fossil. Several US research teams are comparing the light patterns reflected by 3I Atlas with archival data from the Stardust and OSIRIS-REx missions to find signs of primordial matter before the formation of the solar system. Although it is nearly impossible to accurately track its orbit in deep space, modern orbital simulations allow us to reconstruct 3I Atlas's journey over the past 10 million years. During that time, it has passed by at least 93 stars, but it has never come as close to any of them as it did to the Sun. The closest it has ever come to another star was just 3 light years, or 63,000 AU. This is especially impressive when compared to the 4 AU, less than 210 million kilometers, that 3 Atlas reached when it approached the Sun on October 29, 2025. US scientists describe this as an extremely rare astronomical encounter because in its tens of millions of years of travel, 3I Atlas has never come this close to a star, although officially announced on July 1, 2025, traces of 3I Atlas were actually detected as early as May 7 inches data from NASA's TESS exoplanet hunting satellite. For nearly a month, TESS monitored the object's optical signature as it approached Jupiter's orbit, recording brightness variations. that allowed scientists to analyze its core structure and the chemical composition. NASA is now using test data in conjunction with observations from the Atlas system, the Pan-STARRS telescope in Hawaii, and the Deep Space Network to reconstruct the behavior of 3I Atlas as it leaves the solar system. The combination of its ancient galactic origins, unusual speed, and the hyperbolic orbit has caught the attention of the American research community. More than just an interstellar comet, 3I Atlas is becoming a strategic target for leading laboratories, hoping to unlock the distant mysteries of the Milky Way and even open a new debate about the possibility of artificial objects from elsewhere in the universe. During the observation period, 3I Atlas moved about 1 astronomical unit closer to the Sun. Theoretically, the object's reflected brightness, known as its flux, should have increased by only a factor of 1. However, the actual data showed a 5-fold increase in brightness, much larger than expected. This showed that 3I Atlas's surface reflected light more strongly than a typical asteroid. And that's when astronomers realized that it wasn't an asteroid, but an active comet that was starting to form a layer of gas and dust that reflected sunlight. Subsequent optical observations revealed another strange phenomenon. The light reflected by 3I Atlas was negatively polarized, an extremely rare phenomenon in the universe. In most cases, when sunlight is reflected by dust or gas surrounding an object, it is scattered perpendicular to the light source, resulting in a positive polarization. Comets in the solar system, including 3 Borisov, possess this property. However, 3I Atlas reflects light parallel to the light source, resulting in the strongest negative polarization ever recorded. Scientists believe this phenomenon could reveal the unique nature of 3I Atlas, which is completely different from any other comet ever observed. This suggests that other planetary systems in the Milky Way may follow very different physical laws than those we know in our solar system. The second surprise was the composition of the comet's tail. While comets in the solar system are mostly made of water ice, 3I Atlas contained 8 times more carbon dioxide than water vapor. This means that carbon dioxide, also known as dry ice, is the main component of this comet. When heated, dry ice sublimates directly from a solid to a gas, creating a distinctive glowing fog similar to the smoke effects used in terrestrial programs. What's even more surprising is that 3I Atlas began its sublimation from a distance of more than 5 AU, meaning it was still outside the orbit of Jupiter. Something that's almost unheard of for an inner comet. This suggests that 3I Atlas may have formed in a much colder environment than our solar system, where carbon dioxide ice is stable and dominant. The unusual characteristics of its light, gas composition, and reflection suggest that 3I Atlas is not simply a comet, but maybe a primordial fragment of an entirely different star system, one with different physical laws, chemical composition, and planet-forming conditions than we know. Every bit of data collected by 3I Atlas is a valuable piece in the puzzle of how planetary systems form and evolve. And despite its brief passing through the solar system, this interstellar visitor may have provided humanity with one of the most important clues yet about the origins of the universe. 3I Atlas comets begin to form gas clouds early in their journey to the solar system. As carbon dioxide ice sublimates at much lower temperatures than water ice, this allows them to become aerodynamically active in the cold, distant regions where most other comets remain dormant. But as they get closer to the Sun, especially in late September, at distances above 1.5 AU, the ratio of carbon dioxide to water vapor suddenly reverses. The comet spews out a huge amount of water vapor, many times more powerful than usual, suggesting that its core contains layers of material that behave differently than those found in other solar system comets. Another surprising finding came from the metal composition of the comet's tail. Scientists noted an abundance of nickel, but no iron, a near impossible occurrence, since the two metals are often found together in the cores of stars and meteorites. At such low temperatures and distances, it's rare for nickel to vaporize, let alone separate from iron. It's been hypothesized that sublimating carbon dioxide pulled nickel from the core, but the reason for the iron's temporary absence remains unclear. By late September, as Tracy Atlas came closer, iron suddenly reappeared, bringing the metal ratio back to a stable level. This suggests that the deep layers of the comet's core are dissolving, revealing an unprecedentedly complex chemical structure that could be a sign of formation conditions far removed from those in the solar system. This data reinforce the idea that 3I Atlas is a completely unusual comet with a chemical composition and structure unlike anything else we have ever observed. If analyzed further, it could become an important piece in our understanding of the formation of distant planetary systems, especially those in the ancient thick disk region of the Milky Way, where 3I Atlas is thought to have originated. Not only different in composition, 3I Atlas also surprised with the shape of its comet tail. When first observed in summer, its tail did not point away from the Sun as usual, but towards the Sun, an extremely rare phenomenon. Normally, the solar wind blows dust and gas to the opposite side, creating the long tail we're familiar with. But for 3I Atlas, the strong sublimation of carbon dioxide at a distance causes the dust cloud to form, while the solar wind is still too weak to blow it away. So the dust accumulates on the warmer sun-facing side before being pushed away as the solar wind strengthens. By September, Tracy Atlas's tail had stabilized. A short fan-shaped band of gas appeared, this time pointing in the same direction as a typical comet's. However, the length and brightness of the tail depend largely on its distance from the Sun and the gas composition. Comet Hale-Bopp formed a tail that stretched tens of millions of kilometers when it came as close as 9 AU in 1997. 3I Atlas, meanwhile, only approached about 1.4 AU, making its tail shorter and fainter, though it still retained the unusual chemical properties that have astonished astronomers. All of these observations are placing 3I Atlas in the position of one of the strangest interstellar objects ever to pass through the solar system, a priority research target for major scientific agencies, including US observatories that are tracking the comet's slightest fluctuations to better understand its true origins. On October 3I Atlas flew past Mars at a distance of just 19 AU, marking the closest approach the interstellar object has ever made to any planet in the solar system. The rare event was an instant boon for all the scientific instruments operating around the red planet. NASA's Perseverance rover, which is searching for traces of ancient life on Mars, turned its lens to the night sky and captured a 30-second exposure of 3I Atlas as a faint streak of light, but enough to confirm its location Shortly afterward, the European Space Agency's ExoMars orbiter also captured a clearer image, though it still lacked the resolution to accurately distinguish the comet's tail from its core. Still, experts say the data is historic. For the first time in history, an interstellar object has been photographed from the surface and orbit of a world other than Earth. To better understand dry Atlas's structure, scientists are awaiting high-resolution images from NASA's Mars Reconnaissance Orbiter MRO, which has the most powerful high-rise telescope ever orbiting a planet. However, the release of the data has been delayed by NASA's partial shutdown during the US government shutdown, creating an unexpected lull in the US scientific community, which was hoping for images that would clearly show whether 3I Atlas's core is disintegrating or still structurally intact. Astronomers still have time before 3I Atlas leaves our view, though the Sun will continue to eclipse it until early December, and then on December 19, the interstellar object will come within 1 AU of Earth. This will be our last chance to observe it with ground-based telescopes before 3I Atlas leaves our solar system forever. Another important milestone to look forward to is March 16, 2026, when 3I Atlas will fly by Jupiter at a distance of 36 AU. This may be the last chance to get a close-up image of it, thanks to NASA's Juno spacecraft, which has spent more than a decade studying the gas giant and its moons. At this distance, 3I Atlas will cool rapidly, causing sublimation activity to wane. However, comparing the changes before and after its close pass to the Sun could reveal secrets about the evolution of interstellar matter, as some researchers in the US and Europe have suggested that 3I Atlas's unusual features may not only reflect its origin, but also what it has accumulated over billions of years of wandering among the stars, a process no object in the solar system has undergone. For now, there are more questions than answers. Will 3I Atlas be strong enough to survive perihelion? Or will it be shattered by the Sun's heat and disintegrate into countless fragments? Whatever the outcome, 3I Atlas has become one of the most important astronomical discoveries of the decade, significantly expanding humanity's understanding of interstellar objects. Silent messengers carrying the story of the Milky Way's most distant past. If you want to follow 3I Atlas's strange journey as it continues to reveal its secrets, subscribe to the channel and turn on notifications. I'll update as new data becomes available, especially after perigee, when we'll get a clear look at how 3I Atlas has changed after its challenging encounter with the Sun. Don't forget to leave a comment and share your thoughts. Do you think the 3I Atlas will survive intact, or are we about to see it shatter before humanity's eyes? I read all the comments and look forward to hearing your predictions.